Namaste everyone, welcome again to the class. Now in this lecture we will see the practical problems on union and intersection of two sets. So it is better to see practical problems using the problems of exercise. So let us move to exercise 1.6. Now if x and y are the two sets such that n of x is equals to 17, n of y is equal to 23, n of x union y is 38, then what is n of x intersection y? Okay. So, but before we attempt this problem, let us first understand using the Venn diagram what is cardinal number of any set. I think we have discussed the cardinal number. Let us revise it again. So, if set A include number say 1, 2, 3, 4 and 5 and say 6 and say 10, okay. So it's a cardinal number n of A. Cardinal number of this set will be 1. I will count all the elements present here 1, 2, 3, 4, 5, 6 and 7. Total 7 elements are there. So n of A is 7. So this is what we understand by cardinal number. Now number of A union B, if there are two sets, then number of A union B, let us see this with the help of this Venn diagram. Suppose this is A and this is B. Now I have to find number of A union B. So number of A union B will be this part plus this part plus this intersection part. This is what number of A union B. So number of A union B will be, now this part which I discussed is number of A minus B, you can say. This second part is number of B minus A, and then this middle part is number of A intersection B. Okay. Now what I will do, in this I will add number of A intersection B and subtract. So this is equals to number of A minus B plus number of B minus A plus number of A intersection B plus number of A intersection B and minus number of A intersection B. So this number of A minus B plus number of A intersection B, they add up and they will give me number of A. Similarly, number of B minus A and number of A intersection B, they add up and they will give me number of B minus number of A intersection B. Okay. So this is, we discussed the formula how we arrive number of A union B. So number of A union B is number of A plus number of B minus number of A intersection B. Now if there are three sets, actually we will not see problem with three sets, but if there are three sets, or here if these two sets are disjoint, then number of A intersection B will be 0 and we have number of A plus number of B. So for disjoint sets, I will say that for disjoint sets, number of A union B is number of A plus number of B. This is number of A union B. This is for disjoint sets. Now for three sets, number of A union B union C. Okay. Now three sets means we have, this is universal set, then set A, set B and there might be some set C. They are intersecting like this. Then number of A union B union C is, it is number of A plus number of B plus number of C minus number of A intersection B minus number of B intersection C minus number of A intersection C plus number of A intersection B intersection C. Okay, this is number of A union B union C for 3 sets. Done. Okay. So now let us see the problems. First problem, n of x is given, n of y is given, n of x union y is given, and we have to find n of x intersection y. So we will first write what is this n of x union y. N of x union y is what? N of x plus n of y minus n of x intersection y. So this will be equals to n of x union y is 38. This value is 38. Here n of x is 17. N of y is 23. N of x intersection y we don't know. So this n of x intersection y will be equal to, now we will add them. So this is 40 minus this 38 will come on right hand side, so it will become minus 38, and our result is 2. So I will say that number of x intersection y is 2. Number of x intersection y is 2. Okay, this is first question. Now let us see the second question. So for second question, second question is, if x and y are two sets such that x union y has 18 element, x has 8 element and y has 15 element, how many element does x intersection y has? So again the problem is exactly same as question number 1. You can solve yourself. Now third question is, in a group of 400 people, 250 speak Hindi, 200 speak English. How many people can speak both Hindi and English? Now here I will assume that this group either speaks Hindi or English, means at least one language they are speaking. So here if I define H as set of Hindi speaking people, and E as set of English speaking persons, then number of H intersection E, means they are either speaking Hindi or English, will be 400. Number of Hindi speaking people will be 250, and number of English speaking people will be equal to 200. Now I have to find how many people speak both the language, means number of Hindi intersection English. This is a question mark. So again you apply the formula. The formula is simple. We have number of Hindi speaking people union English speaking people is equals to number of H plus number of E minus number of H intersection E. Okay, so number of H intersection E is 400. Here the value is 400. N of H is, this is 250 plus English it is 200 minus this is unknown. So therefore we have 400 equal to, this is 450 minus N of H intersection E. So I will bring this negative on left. I will get number of H intersection E is equals to, here it is 450 minus 400. So that gives the value 50. So therefore, number of people who speak both the language, I will say that therefore number of persons who speak both Hindi and English are 50. So number of people who speak both the language is 50. Okay. Now let us see the fourth question. If S and T are the two sets such that S has 21 element, T has 32 element, S intersection T has 11 element, how many element does S union T have? So again, fifth question, number of S is given. This is our fifth problem. Number of S is 21. Number of T is 32 and number of S intersection T is 11. We have to find what is number of S union T. This is a question mark. So number of S union T is equals to number of S plus number of T minus number of S intersection T. So this is number of S is 21, number of T is 32 minus 11. So 3 plus 2 5, this is 53 minus 11 is equals to 4 to 42. This is number of S union T. Fifth problem, if X and Y are two sets such that X has 40 element, X union Y has 60 element, X intersection Y has 10 element, how many element does Y have? Okay, so we know the element of X union Y, element of X intersection Y. So easy to calculate how many element Y has. Okay, again in the same way you apply the formula and you will get the answer. Let us do that also. Fifth question. So for fifth problem, I have n of x as 40, n of x union y as 60, n of x intersection y as 10 and n of y we need to find. So n of x union y is n of x plus n of y minus n of x intersection y. N of x union y, this is 60, so I will write 60 is equals to n of x is 4040 plus n of y, so we don't know, minus n of x intersection y, this is 10. So this 60 is equals to 30 plus n of y. Therefore, n of y is equals to 60 minus 30. So 60 minus 30 is 30. Done? Okay. Sixth problem. Let us see this sixth question. In a group of 70 people, 37 like coffee, 52 like tea, and each person like at least one of the two drinks. How many people like both tea and coffee? So, if I define n of C as number of people taking coffee. So it is 37. Number of people taking tea, it is 52. Number of people taking coffee or tea, it is 70. We have to find how many like both coffee and tea. This is question mark. So n of C union T will be n of C plus n of T minus n of C intersection T. So n of C union T, here it is 70. This is equals to n of C is 37 plus n of T is 52 minus n of C intersection T, that we need to find n of C intersection T. So 7 plus 2 9, 5 plus 3 8, 89 minus n of C intersection T, and here it is 70. So therefore n of C intersection T is 89 minus 70. So 89 minus 70, 9 minus 0, 9, 8 minus 7, 1, 19. So n of C intersection T is equals to 19. Right, 6. Now seventh problem. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? Okay, different problem. And how many like tennis? So in a group of 65 people, 40 like cricket. So for seventh question, n of C is given 40, n of C intersection T is given 10. So 10 like both the games, 40 like only to play cricket. How many like tennis only and not cricket? Okay. So I need not have to find n of T, but I have to find n of T only T. Only T means with the help of Venn diagram, let us try to understand it. So let us, this is our universal set of 65 people. Now as nothing is mentioned, we can consider, or the data is not sufficient to understand that if any people is not playing any of the games. So we will assume that okay, they are playing at least one game. So all the 65 they are playing some game, and there may be some person who are playing both the games. So it is like this. So this is 40 people like cricket. So let us say this is a set of cricket, this is a set of tennis. 10 like both. So this part, okay, which I am shading, this is what liking both the games. So this part is what? This part is 10. Complete C is 40. So this complete C is 40. Out of this, 10 is included in both. So this part, if I see, this is going to be 30. How many like tennis only and not cricket? Now I have to find this part. Okay. This part is what? That I have to find out. Means who like tennis and not cricket. So here I will say that key one more information is given me, that key cricket and tennis, if I take both the games, then at least person playing or group playing cricket or tennis, this total number is 65. N of C union B is 65. Now what I have to find is this part. Okay, this part. This part is what? Number of tennis minus number of C intersection T. Okay, I will say that I have to find number of tennis minus number of C intersection tennis. This is my question. That is the number of people who are playing only tennis and not cricket. And finally I have to find how many like tennis. So as we know that n of C union T, n of C union T is, or here I could have written this part as n of tennis minus T minus C also I can have written. Na? I have to subtract cricket player from the tennis player. This is question mark. Now n of C union T is n of C minus T plus n of C intersection T plus n of T minus C. This is n of C union T. Okay, from this Venn diagram we can see that this union is this part plus this part plus this part. Now C union T is given 65 plus n of C minus T plus n of C intersection T. This much is your n of C, which is 40. So this 65 is equals to 40 plus n of T minus C. So n of T minus C is 65 minus 40 is equals to 25. So there are 25 people who play only tennis and no cricket, and number of people who play tennis along with cricket. Okay, so I have to add this part now. So this number of T is number of T minus C plus number of T intersection C. So this is 25 and this is 10. I will get answer is 35. Okay, so difficult problem, 7th one. In other way also we can solve. For that what we will see, first we will find n of T by using the formula n of C union B is equals to n of C plus n of B minus n of C intersection B. By that we can find the value of n of T and then we will subtract the common part and we will get the number of people who play only tennis. So here finally in word I will write, therefore the number of people who play only tennis, is 25 and total number of people playing tennis, total number of people playing tennis is equal to 35. Done. In a committee, 50 people speak French, 20 speak Spanish and 10 speak both Spanish and French. How many speak at least one of the two languages? So 8th question is a simple question. Now what is given? In a committee of 50 people, 50 people speak French, so number of French speaking people is 50. 20 speak Spanish, number of Spanish speaking people is 20. 10 speak both. So number of French intersection Spanish is 10. How many speak at least one of the language? So number of French Union Spanish, that is a question mark. So number of French Union Spanish is number of French plus number of Spanish minus number of French intersection Spanish. So this is 50 plus 20 minus 10. So answer is 60. So there are total 60 people who speak at least one language, French or Spanish. So this is all about your exercise 1.6. By this we have completed all the topics of this chapter set. Now there is a miscellaneous exercise, so we will see one day that miscellaneous exercise also, or you all can try that miscellaneous exercise by yourself. So thank you for being with me. We will see you in the next class, maybe with a new chapter. Thank you once again.